Hello, everyone. Welcome to our session here at ICE Conference. We're very happy to be here today representing Platige and talking to you about Unreal Engine in cinematic context and answering all the questions you may have. So without any further ado, lights, camera, Unreal, redefining the cinematic workflow at Platige. Let's start by properly introducing ourselves. Hello, my name is Sara. I'm a Portuguese software engineer. My career started in the game industry, where I was developing prototypes in the R&D department and porting games to several consoles. I also worked as a professor, teaching several tech courses, including an Unreal Engine 5 course. And a few years ago, I switched to the animation and VFX industry, where I joined Platige as an R&D developer. And here I was mostly researching the new Unreal 5 features to support the projects and the artists and develop our cinematic pipeline. More recently, I stepped into the role of team and project manager, where I continue to support our dear pipeline and R&D teams and projects. And that's a little bit about me.
Thank you. Let me introduce myself. Hi, I'm Zoltán Cseri, and I'm a senior R&D developer at Platige. I finished education as an ICT engineer that specializes in real-time engines, and I was lucky enough to work in different areas such as AR, VR, virtual production, and motion capture. But lately I was focusing more on tools and pipeline development. So I have over a little bit of 8 years of experience with real-time engines, and that's enough about me. So I'll get back to you.
Thank you. So these are the topics that we have prepared for you today. We will continue with our introductions as we talk you through the work we do in Platige and in the R&D department. Next up, we'll discuss the main challenges we face in cinematic production and how Unreal fits in all of this. And following up, we'll select two Unreal projects to showcase today, the Aston Martin commercial and the War Heaven cinematic. And hopefully by comparing these two projects, we'll be able to show you the importance and impact that having a defined workflow and tailored tools can really have on your projects. And in the end, we'll wrap everything up with a few conclusions and we'll save some time for a little Q&A. So let's continue with our introductions and talk a little bit about Platige. We are a creative studio with nearly 30 years of experience in production, post-production projects, in film, advertising, and game industries. We work worldwide, have physical offices all around the world in Los Angeles, Montreal, Tokyo, and our headquarters are in Warsaw, Poland. Thanks to our global presence, we did reach cross borders with our reputation, so we serve a diverse clientele in film, advertising, entertainment, and television. And we received over 300 awards over the past years. Amongst them are BAFTA, Webby, SIGGRAPH, Animago, and the European Film Award for Best Animated Feature. We also received nominations for Palme d'Or in Cannes and, of course, the Academy Award. But we all know that images tell more than words, so let's take a look at our show reel.
Look what we can do.
Ciao. I absolutely love this ciao in the end. So to produce all of these wonderful projects, we have very talented and specialized teams and departments inside Platige. And for today, we wanted to focus your attention towards our dear R&D department. Since our main purpose is to support the Unreal pipeline, it makes sense for us to share a little bit of what we do on our day-to-day work. So part of our tasks are to research and test the new released features and plugins from Unreal Engine 5. We then write internal documentation to make sure we document all our findings. We conduct and prepare training sessions and presentations for our artists to share the knowledge with all the teams. We develop tools and features to enhance our pipeline and support the artists in the projects further. And we do, of course, some bug fixing and project support as it's needed. As I mentioned before, we will dive into some of the main challenges we face in cinematic production. So let's discuss them right now. The first thing is, how do we create believable visuals and storytelling? So we are trained since kids to identify what looks like a realistic tree or a fire effect and what doesn't. So even if you don't know exactly the technical or physical details of a water simulation, for example, you do know what the wave looks like. So when we are creating our effects and stories, we need to keep this in mind to develop effects that trick our brain into thinking that this is real, even though it's CG. Then, if we want to push the boundaries to achieve high-quality visuals and storytelling, we are, of course, increasing the technical complexity. And we don't have unlimited resources, so there's always some time constraints that we need to respect. Also, the technology is changing in such a rapid pace that we need to keep track of all the latest updates, incorporate those changes, and keep everything still working as expected. And on its own, this is already a big challenge. We might face some technical constraints as we need to, do some bug fixes and alterations on the go as the project is evolving. And since we have several departments working together to keep this effective and clear communication between the artists, programmers, directors, supervisors, you name it, we do need to be very organized, perseverant, and dedicated to deliver this final product. So there's a lot of constraints that we have to work to make sure we have the chance to deliver this amazing product in the end. So the question now is, why Unreal? How does it fit in all of this? So let me share with you the brief chronology of how we integrated Unreal in Platige. So it all started back in 2020 with our first projects in Unreal. So the name was Koala, and it was done in Unreal Engine 4. A year after, we now have our R&D department taking charge of developing the pipeline and the proper tools to support the Unreal projects. And another year passes, and we now have other departments embarking on this adventure to use Unreal Engine for cinematic projects. So we have creative arts and commercials joining the teams. And back in 2023, we became authorized service partners with Epic, and we are very proud of this achievement. And it really highlights all our hard work and dedication and expertise with Unreal Engine. So, since 2021, we've produced over 30 projects in Unreal in various areas such as virtual production, broadcast, game cinematics, commercials, short films, etc., etc. So as you can see, we do like to push all the boundaries of Unreal. So now that we know how Unreal was integrated in Platige, let's analyze a bit its pros and cons. So let's answer this question: why Unreal? There are a lot of main advantages to using Unreal. For example, the real-time visualization, I would say this is the biggest one, because it does give us this ability to quickly visualize the scenes, the frame shots, and experiment within the level, all in real time. We can very easily implement state-of-the-art visuals. It does have integration with other software such as Houdini and Maya. Having the source code available is a great advantage because even when we don't have documentation about a certain feature, we can still investigate and dive deep into the source code and just understand how Epic engineers are really thinking about that feature and what they are aiming for when they are coding it. So having the source code available, it's a huge advantage. It is very friendly for non-programmers because you can not only program in C++ or Python, but you can also use blueprints. And it ends up being a bit more friendly for non-programmers. And having access to multiple assets from the community, like Megascans or even other products, really speeds up the whole process of creating the scenes and creating the assets. So we don't have to worry about having to create every single one. We can also use assets available for us in the markets. But of course, Unreal also has its caveats, and we don't want to leave you without making sure you know where you're getting yourselves into when you're working with such a powerful tool. So these are the main challenges that we face when we are working with Unreal. First thing is that it is quite a complex interface to get to learn, and there's a steep learning curve here, even though right now there's a lot of tutorials online already available and a lot of resources, but it's still quite challenging to learn every single aspect of the engine. There is some lack of documentation for certain features, but again, having the source code can help mitigate this challenge a little bit. So you can, like I mentioned, you can dive into these features in the source code and just understand, even by the comments that the engineers are leaving, understand a bit better what they are aiming with that. But nevertheless, there is some lack of documentation sometimes for certain workflows. It does run better on Windows, so if you have a Linux-based environment setup, just take this into consideration. It has surface integration, which is great for us, but just keeping in mind that it's not very artist-friendly. And there is some lack of some workflows. For example, the stereo, but this is something that Epic is constantly working on, trying to mitigate and trying to add on new workflows. But of course, there's still some lack and some room for improvements. And the last three things are kind of similar in a sense, because it's quite tricky to maintain and to manage the render farm. Same thing with keeping a fork of the Unreal repository. And to give an idea, when we are building our engine, right now with Unreal 5.6, it is taking nearly 14 hours to compile the whole thing. So it does take a long time to build the engine. So just to give you this rough idea. So with this being said, let's have a sneak peek into the making of our two Unreal projects. The first one that we'll take a look is Aston Martin commercial. So here the client was wishing for this very elegant marble environment with crystal effects, and most of the effects were made in Unreal, but we did use Compo after very heavily. So yeah, let's take a look at the final product, and I'll be back with a few more snippets of it. I really hope you enjoyed. So let's take a look at project breakdown. There's two main ideas here to address. So the first one is that back then we didn't have many technical skilled artists in Unreal. It was quite a new engine and we didn't have a lot of experience with it back then. So a lot of effects were done in Houdini, Nuke, and other softwares simply because the teams were more used to those softwares than using Unreal. And the second thing here is that we made the project in using Unreal Engine 5 beta version. So we did experience a lot of crashes. And the decision here was very simple. First thing, we wanted to make use of a lot of the new features like Illumin and Nanite. And the second thing is that the client really liked the idea of working with this new technology. So that's why we went with this more unstable version of the engine instead of using Unreal Engine 4 like we did for Koala Project, for example. But these are two very important points that we had to deal with in the beginning. So speaking about some highlights, I will just show you briefly how we implemented this marble procedural shader, the crystals procedural shader, and the buildings around the whole city, because we did them with procedural blueprints and splines. So yeah, let's take a little look at those. So everything started with this real-world reference of the marble. Our artist, Adrian Klimczak, he was analyzing it, trying to study how it was reacting to different lights and different environments. And this was a procedural shader that was made completely in Unreal by our team. We could change the 3D world scale, the roughness, and all the global parameters. And it was based in a real-world material reference. So the author of this shader was analyzing how it behaves, again, with lighting, with the reflections, and really trying to approximate the results, the digital results, to the real-life reference. So you can see here a bit more of the controls we needed. Next thing is the crystals. So for the crystals, we did create another shader that was also made procedurally. There was no substance painter used, and it was made possible to reuse all the meshes. And in case you're curious, these crystals are all made entirely with Niagara particles. So as you can see, they have this main source, and then they start growing from that point forward until they become very huge. As for the buildings, we did create this procedural blueprint that was mostly operating with splines. And yeah, it was essentially generating all the floors, flats, and other buildings based on how we were placing our splines in the world. And yeah, it just made it very, very simple and quick to populate the whole area that we wanted to shoot our car. So very cool things that we were able to do, even with little experience back then in Unreal Engine. So sharing a few conclusions about this project. Not every artist was familiar with Unreal back then. We did use the beta version, so it was quite unstable and it did cause a lot of crashes, so we had to overcome all of those challenges. And back then, there was no existing pipeline to support the project, no tools to enhance the efficiency or even to support and help our artists. So this Aston Martin project really made us think that we needed to implement our proper pipeline to really support and improve the efficiency of our artists. So that's what we did after, and this other project we're having is we'll share a few lights around it. So Zoltán, if you could please take it away.
Thank you very much, Sara. So as for the second project, we are proud to show you the Warhaven cinematic teaser. It is a unique project because most of the visual effects and simulations were done in Unreal, from cloth simulation to explosions, fire, and turning a character into a stone. But let's see all that in action. So let me just show you the reveal trailer.
Hear the battle call, cities rise and empires fall, but it's a war worth fighting. We're taking up our arms, held the line up, here we charge, and we keep on fighting. It's a war worth fighting.
Alright, so this is a shorter version of the cinematic, but there is also a longer one. So I definitely recommend, if you have the time, to check it out yourself because it's really, really amazing. So as for the project breakdown, we could see that since Aston Martin project, we hired more people who were experienced with Unreal Engine, and also the older artists who started to learn Unreal, they really figure out like why it is so amazing, and they started to learn every aspect of Unreal, and it was really easy to see in the end result as well that we managed to do much better. Also, this was a project in which we wanted to use Unreal as much as possible. Also, we used the full release version of Unreal Engine 5, so it was much more stable. We didn't have that many crashes, but we could still utilize most of the latest amazing features. Also, thanks to Unreal Engine, we were able to pull a lot of content from the client's project directly. That helped a lot to speed up the creation processes. Of course, we had to add more details to achieve the cinematic look, but it was a good base to start from. Finally, we used motion captured character animations that were recorded in our own studio to get the fluid motion what we wanted to achieve. Now, as for the technical highlights, I want to show you 4 different things: the cinematic fire, the slow motion effect, the transforming characters into stone blueprint, and the rendering solutions. So as for the cinematic fire, one of our artists, Damien Mishra, has created a package with photorealistic visual effects. They were used in that project really heavily, and they are published on the Epic Marketplace. In its blueprint, it's a flip book that was generated with Embergen, but with some extra features. So you can adjust the rotation, you can adjust the emissivity and the lights itself. Now, as for the slow motion effects, in Unreal, we can control many features which are usually made in post-production. Here we used the option called time dilatation, which was controlling the slow motion effect directly in Unreal. And it's really amazing because you can alter the time, how we use the time effect in Unreal. Transforming characters into stone blueprint. Kasper Barthy was responsible for making this blueprint, which was turning a character into stone pieces. It was a huge step because normally we had to use Houdini to generate heavy caches for every shot, which consumes time and human resources. But thanks to this blueprint, we could generate physics in real time. Now as for the rendering solutions, some effects cannot be created directly in Unreal. In this scenario, we are rendering passes, which are very handy to add the shots in Nuke. And in the current shot, what you could see, we used a logo crypto to create the fade-in effect. But we can render out many other different crypto masks, such as ambient occlusions or word depth. Now for the project conclusions. The most challenging part was the organization and planning of the project, as we spent a lot of time figuring out what is the proper structure that we want to work with, and inside the project, and also like how the artists should work after each other. But it was finalized in the end. Thankfully, we had a much more experienced team in Unreal in this project, which is really visible in the end result. And also, we were mixing both the traditional CG pipeline along with the Unreal pipeline to support the project and in the artist work. So we created the tools that were required to render out shots, importing shots, and also to speed up their processes. On top of all this, we added a bunch of tailored tools to speed up the artist work. Without this, simply we couldn't just finish the project. With all this in respect, the Warhaven project was completed 2 weeks before the final deadline, so it really shows how powerful Unreal is. Now for the workflow, tools and technologies, I want to show you that I want to show you in the following sections in the presentation to give a brief introduction to how we design the workflow, tools, and some automated processes that we developed in the R&D team. But first, let's state what kind of technology stack we are running. So our studio is currently running 5.6 version of Unreal Engine, benefiting from these latest features and enhancements, such as MetaHuman pipeline, PCGs, and many more. We also maintain our own build of the Unreal Engine, which allows us to quickly test the in-house plugins and do faster upgrades in production. As for easing up the installation process, we made a simple command line installer that downloads the required engine from GitLab releases and extracts it to the artist's computer. This was a must-have feature, as artists can handle the installation processes themselves, eliminating the need for IT involvement or assistance. Of course, we needed the version control our projects and tools, so we rely on Perforce and Git to do the rest of the magic. Now for the workflow, Res is our principal package manager at the studio. We build our Unreal plugins with it, while also deploying the latest changes to the production Perforce server weekly. But we don't want to force the artists to render out everything manually on their machines, so we need to delegate those renders to the render nodes via deadline. For that, we created a custom deadline plugin that ensures that we have proper engine version and sync the latest revision before rendering. In that case, the artists are responsible for keeping the changes up to date before they're sending out the renders. ShotGrid is our main asset tracking, project management, and review platform. It was important for our artists to have the ability to publish previews from the Unreal into ShotGrid, because we had to render out multiple shots at the same time. And it was important to create a tool that would allow the artist to render multiple shots at once and publish the movies to ShotGrid to showcase their progress to the supervisors and the clients. We are also utilizing the shared DDC to optimize the shader compilation times. And also we are virtualizing the textures and static meshes to provide faster sync times between Perforce. Also, we are using a custom fork of the engine. And we stay very close to the vanilla version, but we are removing some project templates, utilities, documentations, and debug symbols. And with these optimizations, we have a build size around 27 gigabytes. It is still quite large, but now it's manageable. Now, as for the automation, as we are a very small team, we wanted to initially spend some time to automate the task so we can keep developing features that we want to do instead of doing all the manual work and building an engine or deploying the changes to the production. So as an example, we have automated us to building new versions of the engine with GitLab CI. We are using the Unreal Build tool with a build graph to adjust and trim down the size of the engine. Also, we have a scheduled jobs for our plugins that will distribute the changes automatically to the running projects. It is really, really useful because with this one, we could eliminate the human error factor. Now let's talk about our most used tools in our pipeline. One of them is the shot builder. And as you can see, we have all the necessary information, what we need for building up the shots. So the names, descriptions, start frame, end frame, and the cut in and cut out range. On top of that, we have the status on the right side, so we can see if it has any problems, if it is up to date, or it is not imported. On top of this, we have the ability to add additional categories on the lower left side, so characters, VFX, props, and previews. And now let's see that in action. So in the upper menu, we have our own tools. We can open up the shots that are available in the project, and we can select either one or multiple ones. I added 2 additional categories and importing the shots. The system will connect to ShotGrid, getting all the information that is connected to the shots itself, and the tool is going to create the necessary project structure along with the levels and sublevels. We decided to go with the levels and sublevels approach for better control over the content. But if you are working with word partition, instead of sublevels, we are going to use just the data layers. Also, we created a custom container class, which is storing all the information that is required for the shots itself. Now for the second tool, we have the render manager. On the left side, we have the list of available shots that were imported. And on the right side, we have the render options where we can select how do we want to render out with the movie render queue configuration, if you want to generate previews or we want to add in any kind of comments to the preview. And also we are able to delegate it to machines with predefined VRAMs, or if you want to render out only custom frame ranges. But let's see that in action. So as the first, we are going to render out the shots locally. So we select one of them. Also, we can open up the levels and sequences, so the artists don't have to navigate it in the content browser. And if we go back to the render manager, on the right side, we can select the VRAM, the custom frame ranges if we wanted to do that, or just write any kind of comment that we want. And after pressing the big green button, we will be able to see that the movie render queue is going to be built and is rendered out immediately. So as you selected the generate preview, it will automatically convert the image sequence into a movie, and it's going to be uploaded to ShotGrid. So when we refresh the page and open up the shot itself, we can see that the comment is already there and it's ready to be reviewed by any kind of supervisor. Now for the next one is going to be the deadline integration. It is very similar. The only difference is that we don't render it out locally, but we render it out remotely on a predefined render node. And what it's going to do that first, the system is going to pick up the render job. It's going to make sure that the project predefined engine is installed on the machine. If it is not, it's going to download it from our repository, install it on their machine, and then it's going to get the latest version from Perforce. So it ensures that it's always the latest changes what we have there, and it is the artist's work to make sure that everything is submitted before. After that, the whole render is going to start, and we can see it just started. So after it's finishing, it's always going to be uploaded to the ShotGrid. And when we open it up, we have the preview to be reviewed. And there it goes. Now, as for the conclusion, what we can give you after 4 years of developing the Unreal Engine pipeline. Having a solid naming convention along with the project structure can make wonders in the long run. Also, not everything is exposed in Python API. You can still do a lot of things with the combination of Python and blueprints, but using C++, it's almost mandatory if you want to really extend the engine functionalities. We especially benefited from creating own blueprint library to expose certain functionalities like reloading open color IO configs, creating movie pipeline configs, or creating specific assets. Also, UDN is the best place to get answers if you are stuck. And even with beefy workstations and GPUs with a lot of VRAM, you will hit the limit quickly. Therefore, educating artists to optimizing their assets and scenes is a must. Also, our primary OS is the Windows in the studio, which makes things significantly easier. So thank you very much for your attention, and now we are ready for the Q&A.
Thank you, guys.
Very cool. All right. Sweet. So it's a pleasure to have you here, Zoltán. And yeah, I got a couple of questions, but before we even start with the Q&A, congrats for the cool presentation, and thank you. Thanks to you, and also obviously to Sara. Yeah, but maybe because we have multiple people joining from different industries like architecture and GIS and so on and so on. Maybe you can give just a tiny little bit of an overview over Platige, also in the sense of, are there different departments, or how big is the company, if you know, like a little bit of kind of some of those aspects.
Yes. First of all, thank you very much for having us here at this conference. It's really a pleasure to be here. Mm-hmm. And yes, you know, if we're talking about Platige, we have different offices, as Sara mentioned as well. Like we are based in Poland, as that's our headquarters, but we are also based in the US, in Japan. We lately opened up one other in Gran Canaria, and I think we are around 200, 300, 400 people employed in Platige. But yes, we have a lot of different departments like commercial, entertainment, broadcasts. We are doing all kinds of work. So we are doing a lot of work in different areas, and that's why we're so spread out, because there are so many things that we're doing at the same time.
Yeah, but so the origins, I guess maybe some people don't know that, but the origins where you get some like massive amounts of awards and so on is in game cinematics. That's kind of the classic business field where you got the major breakthrough, and then from there you start. Platige started to venture into different directions. And one of the things I didn't see it sadly myself, but one of the things that I saw that wasn't even mentioned yet, kind of in the presentation of what you just showed there, is that you were, I believe, invited by Netflix also to work on one of the episodes, or provide one of the episodes of Love, Death and Robots.
Yes.
And,
yeah, we did one.
Something completely different, right? But it shows the scope of different types of projects that you are delivering.
Yeah, like if I could just add to it, like also like we made one episode in secret level, and it was the Crossfire. We also got some awards for it. So you could see like we are even though we started with game cinematics, we are doing also like shorts. We made one called Little Ruby. It was like a more stylized short. It was our own production, but it was also done initially in Unreal. So that shows that how versatile we can use Unreal. So it is not just, you know, the fully photorealistic approach that we can go to, but more the stylized one as well. So that's why it is so beautiful to use the real-time engine itself.
I was curious. So before going into the questions of the audience, but because let's say the choice to go towards using Unreal, for example, as a, let's say, a visualization, let's say, platform, you could say, or tool in general for multiple things in general. Is that somehow, that decision somehow related to that some of your clients originally were basically game studios and, let's say, ingesting game-ready assets that could potentially be converted to be used in cinematics might have been easier also? Or is it more an, let's say, a versatility, efficiency decision?
I think the whole origin started that there was a time when we realized that the whole rendering pipeline, what we have, it's kind of rigid. Like we had the offline cinematic workflow, and it takes a huge amount of time to render out everything. And as you said, like most of our clients were like game related, it made sense to adapt the new technology. And also we could see that after we made some tests with Unreal Engine that it is really capable of doing the cinematics what we achieved so far. And if we wanted to keep that level, first we had to test out if it is working, and if it is working, then we really jumped into. So I was part of the first hires that established the whole Unreal pipeline in Unreal or in Platige, and it slowly built it up. So when we realized that it's working, that we tried to do more and more into Unreal itself. And that's why I think last year it was, until last year, the whole 50% of the total project was done in Unreal in Platige. So even though we were with just 4 years or 5 years with Unreal, we started to grow on us. And also we could see that we are achieving really amazing results.
Very cool, very cool. All right, so let's address some of the questions coming from the audience. So Pablo asks, how did you manage the compatibility between different versions of the software, so Unreal, or do you guys commit to the same version through a particular project?
Yeah, like usually when we are going with one project, like that's usually lasts like a few months, and we don't switch Unreal Engine versions unless it is really necessary. So if we start, let's say, with 5.4, then we go with it until the project lasts, unless there is some must-have feature that releases with 5.5 or something that is required by the artist or the client itself. And regarding our tools, like we always try to keep up with the latest changes. So if something comes up, like we compile it and then we just use it. And that's what we are going to use for the next project itself.
Is maybe adding to that, is it, I assume it's a big advantage that you have access to the full source code also, I assume.
Yes.
I mean, you mentioned C++ before too, if you really want to go low level, or if you cannot have access to certain things that are not exposed in the API. We saw this in-house also in past. So it's, I guess that may have been also like skewing the choice to go towards Unreal because of that, I assume.
Yeah, and also like we can alter it however we want it, but also because of the sheer number of tools that Epic developed for Unreal itself, like it was already a base that you can build on top of it. So one of the things what we had to do in the very beginning when we started to work with Unreal, to compare the two pipelines, like the traditional CG pipeline and the new Unreal pipeline, that what do we have to migrate, or recreate in the Unreal sense. And when we establish those things, like importing shots, rendering out shots, and then creating the previews, then we knew that we can create those tools with use of C++ and then plugins itself. So having the full control over it was a really amazing result.
Are there, just curious, are there some tools or let's say certain functionality which you actually develop in-house and then push towards Epic to be integrated in the full Unreal package? Has this happened in past?
Like not really. Like we could see that some of the things what we done, it's started to get into the latest releases of Unreal Engine. Not exactly the same thing, but maybe like they get the push from all over the industry that they should have like a master sequence creator that you can just, or you can like a sequence creator so you can create it more easily and you don't have to do it manually, or you can nest these things. So of course we keep in touch with Epic and Unreal, but I can say that like we did this one or they did it because we made it in our house.
All right, cool. All right, so there's another question by Alexandra. She asked, what is the biggest challenge Platige has encountered when working with a mix between traditional CG and Unreal?
I think the biggest trouble or challenge what we faced is like transitioning the artists from the traditional pipeline into the real time, because it's such a difference. Like even though if we just look at it, we think that it's like almost the same, like you're rendering in one software and the other. However, in the traditional CG pipeline, you can like brute force everything. Like you can just feed it million, trillion polygons and it just eats it. And of course, maybe it renders like weeks, but it goes through. In Unreal, you cannot do that. You have to make some optimizations. So you have to make sure that the meshes are somehow optimized. The textures are not too large, so it can still into the VRAMs. And also you have to make sure that everything is working. If you're talking about not just offline rendering, but in-game cinematics, where we have to make sure that it's running like kind of normally in-game itself, then it's even more optimization. So there are different kind of things that we had to learn and figure out.
Nice. All right. Then another question by Pablo. Did you have to use real-world locations? And if so, did you ever use shapefiles? So shapefiles is like a file format basically that stores, let's say, building data and things like that.
I don't know that one if we ever used real life location, maybe for shooting or for some inspiration, but I cannot say it for sure.
Yeah, all right. Sweet. Then there's another question by Alexandra. You mentioned it takes quite a while to build the engine. I believe you said it's around 14 hours. Are there any tools or improvements that you've implemented to mitigate that?
We haven't implemented tools, but we modified the build graph of the engine itself. So it was 14 hours for the previous version. Now with the latest version, I think it's only 7 hours. So they made some magic behind in Epic, so we are really happy about it. But in general, what we do, that we try to remove any templates or debug symbols or any kind of things that we don't need it. And with that one, we are able to save a lot of space and time to build the engine itself. And that's the only thing what we do. Like we haven't created any special tool to make it.
Yeah. No, that makes sense. Yeah, so there's a thank you comment also for answering the questions.
You're welcome.
I have two more small questions before I think we can slowly move on. So when collaborating with multiple people, so I mean, you mentioned world partitions before, or let's say in general, when multiple artists, because the levels or the environments which you're creating sometimes are huge, right? So is there, or what's the workflow, or what are the, let's say, the methodologies, if there are any, where multiple people can literally work on the same level, on the same map, basically, at the same time? Is that something that is actively pushed, or is it more like kind of classic in that sense?
It really depends on the scene. So if you're talking about a very like condensed area, like a room, then we don't need word partition. In that case, like we just use a simple level, and then we try to use sub-levels. So if we have artists that were working on the environment, one of them is working on the props, one of them is working on the characters, then we have 3 or 4 or 5 sub-levels, or even the artist can create more depending on the needs. And in that case, those things are logged or checked out, and they are able to collaborate with each other without any problem. If you're talking about a huge area, like an open world with a huge forest, then we are using the word partition. And thanks to that one, we have the 1 file per actor, which means that everyone can work in the same level without actually like stopping the others to work. And they can just populate it. And when they are done, in Perforce, we can just submit the changes, and it's checking out individual files itself. So it really depends on, of course, the use cases. So we use both.
All right, all right. And so, I mean, one of the topics that we also looked into a bit over the last, let's say, couple of weeks is USD. Bringing in USD data into Unreal, let's say, for if you have large environments or so, to bring them, for example, load them from USD and then translate into whichever thing necessary, let's say world partitions or things like that. Is that something that you're also investigating at the moment? Or USD, Material X, things like that? Or is that something that you say, no, tool's good enough at the moment? Or I'm just curious about that.
Yeah. Yeah, like we always investigate, and USD is also in our minds in general. But what we find out that in Unreal, USD is not like super polished. So there are some limitations, and therefore we go with the current approach of just using normal abaxes or Lambda caches or any kind of thing what we're using to populate the scene. But would be the best to have the USD, because in that case we can communicate with other programs and then just export it from one to another, and we don't have to worry about it. So we investigate it. We hope it's going to be like a fully featured in Unreal, and then we would love to go with that area.
Yeah, let's all push towards it.
Yes.
Cool. So I just saw there was a couple more questions popping in. I don't want to interrupt those. So by Benjamin, have Platige merged Unreal scenes with live action elements, and were you able to figure out consistent color between departments?
All right, so I don't think that we used or mixed live action components or live action scenes with Unreal, but I cannot say it for sure because we are so many departments and I don't overview everyone. So maybe we did, maybe we don't. We did some virtual production, so maybe that's the closest what we can go to the mixing the two scenes. And what was the other question?
That is basically
the consistent color.
Yeah,
the consistent color. Like we are using OCIO that is built in already in Unreal, and then we are just trying to figure out which color map or tone map do we use for outputting the textures. And also we made sure that the OCIO is enabled on the viewports, so the artist can work in the whole colors, color space.
All right. So questions or comments are popping in. There was one more thing. So Pablo asks, there was an article on AT level, I think, about how Unreal goes through 5,500 files when starting up. okay, that's more a comment. Massive or unnecessary files. Okay, a lot of files, but that are unnecessary when starting. There was even a link now to it. All right, it's that wasn't a question. It's more like a technical comment and the link to the article. Yeah, no, but I mean it's been a fantastic start so far. Thank you so much. I would say we're quickly gonna do a 5-minute break, and then we'll be back, and then we'll welcome Michael. So thank you so much so far, and we'll talk again later on. Cheers.
Thank you very much, Matthias.
You're welcome.